Hello everyone. So in this little video, I just want to describe how we read the Vernier caliper and then how we're going to calculate the density of this small aluminum cylinder here. Okay, so Vernier caliper, and I will give you guys a lot more practice. There's a nice simulation online that I will link to. You guys can practice this, but let me just describe this in general. So we have these jaws. This is where you put the object between the two jaws. And basically on the Vernier caliper, there's two scales. You have a main scale, so in this case it goes from like 0 to 6. This is in centimeters. And then you have what's called a Vernier scale that goes from 0 to 10, right? That's on one of the jaws itself that slides, so 0 to 10. And the whole idea here is to read where the 0 is on the main scale. That gives you the distance between the jaws. Okay, so for instance, if I have this, let's say the object was placed in there and I get this particular value. If you look at this, hopefully you guys can see this, the 0 is past the 2.1, so it's 2.1 something. Now to get that last digit, first of all, if we eyeball it, it looks like it's maybe a little more than halfway. So it might be like 2.16 or 2.17, 2.18, somewhere around there. To get that last digit exactly, I look on the Vernier scale, so the 0 through 10, or really 0 through 9, and I ask myself, which one of these lines in the Vernier scale, the 0, the 1, the 2, the 3, lines up best with any line on the main scale? And it turns out that in this case, the 6th one lines up best. So I would read this as 2.16 centimeters. Okay, if the 0, let's say the 0 were right on the line like that. So in this case, it's 2.2, and then the 0 lines up best, so that would be 2.20 centimeters. If I move it a little bit to the right, a tenth, see now the first tick mark on the Vernier scale lines up, so there'd be 2.21. A little more, 2.22, and so on. Okay, so you're reading where the 0 is on the main scale, and then to get that last digit, you're asking yourself which tick mark on the Vernier scale lines up best with any line from above. Okay, so in reality, it'd be nice if we could actually use this, right? This demo. In reality, we have to use the actual Vernier caliper, which is very accurate, but it's a little difficult to read at times. So for this part of the experiment, we want to measure the density of this small aluminum cylinder. So in order to compute density, we need to find the mass, right? That's easy. We can just mass this on our electronic scale, and I'll give you guys all that data. And we also need to find the volume, right? So mass divided by volume would be the density. So how do I find the volume of a cylinder? Well, I need to measure the height, and I need to measure the diameter. So with the Vernier caliper, I'm going to measure the height 5 times. Okay, so I have to read off that value, so 5 measurements. And then the diameter, also 5 times. So 5 measurements of the height, 5 measurements for the diameter. Again, I will give you guys all that data, okay, and that will allow you to calculate the volume of the cylinder as well as the density. And also you'll be able to calculate things like the percent experimental accuracy for the height, for the diameter, for the volume, and so on. Great, thanks.